So where we left off last time, and hopefully you now have a good feel for how we went from that big picture down to this little bit, as we've defined our two problems that we could solve. We're going to solve one of them. We're going to design one of them out here, this knowing the room status. So that all that data, we've come down to a list of objects and the classes that we're going to get them from. Now, when we say objects, the difference between an object and a class is really important here. So in our classroom setting, we talked about this a little bit before, we have two classes that are interacting, teacher, student. I happen to be the only instance of the teacher class. I have X number of students in the class. You are all from the same class. You're instances of said class. Your objects that live out there. Again, I know you're not completely the same. You're not clones. It's an analogy. Don't get too literal within it. But from the function of the way somebody coded the website, that's exactly what you are, is your instances, your rows in a database that get loaded up and do interesting things on. When I submit grades for you, it stores each of your grades the same way in the database. And that's what we're trying to do here, is build code that does that sort of stuff. So I define the classes. I have attributes that's going to store the data from those classes. I have methods that's going to do the behavior. That's what we're driving towards in this modeling activity. So we talked about sensors and monitors here. This is the one we're going to drive in on. For the sensor, we have certain attributes we want to define. So again, there's not necessarily something you would pull out there. I'm pulling some more information there, but you'd get this from various sources. So you'd probably look at the physical sensors that you're going to have in your hand. And you'd have to understand what are the different types of sensors. What's in common with all of them? So if I look at a temperature sensor, if I look at a light meter, if I look at a microphone, again, type of sensor, I look at a humidity sensor, I look at motion detectors, whatever I could be adding inside of there. What are things they all have in common? Well, they probably have stuff like a model number. I want to, in my software, define a unique identifier. So I can tell, oh, this is the sensor that's on the first floor, the second floor, the bedroom, the bathroom, whatever space I want it to be. Some way I can tell it apart from the other ones. Perhaps in a secure world, they have passwords associated with them. If they're Bluetooth devices that could be attached from any system. So, in Bluetooth, they have like the 4-digit code that allows you to pair these things appropriately. And you can't just pair with something unless you have its code. Something we could be storing inside of there. The location code could also be overlapping with the unique ID. The unique ID could just be a serial number, model number, serial number, and then separately from that, I can say, well, where did I put this? What's the location out there? Most of the sensors probably going to have electronics. So is it plugged into a wall somewhere, or is it on battery? And if it's on battery, what's the battery level? Maybe they have backups that are inside of it. These are the things that are common for all sensors I have. Now notice I'm saying common for all sensors I have. We have to define a little bit, how do we represent these sensors in our system? So that's sensors. That's going to be pulling in information. Now notice I'm separating out in my design the storage of information and the device I'm going to get that information from, then what I'm going to do with it, which is the monitoring of it. So I have a list of sensors that I monitor. So I have a different type of monitor, like let's say I have a smoke alarm. One of the things the smoke alarm might check is the heat level in the house. If the temperature goes above 130 degrees, I might be on fire. Could be checking for smoke in the house, which could be a visual sensor. Could be, like maybe just something that if there gets smoke in between it, the particles, it detects the motion of smoke. I mean, again, there's many different ways of detecting smoke inside there. So that list of sensors can help contribute. So if it's foggy but cool, maybe it's not actually fire. It's actually fog. So other things about monitors. When did it run last time? Well, how often should it be run? Is it on or off? And again, this is a software piece, so who's the author and who's the publisher of this? You think of it like an app. It could be the App Store. I can download monitors. So I have all these sensors. Well, now my heat sensor now turns into a party comfort sensor. So if it's too cool in the room, let's turn up the music and get people dancing, and that's going to be an app somebody could sell. Very good one, but it's an app. So that's the data side of it. Let's look at the behavior side of it. What do these things do for me? So sensors, I go ask them for data. Notice there was no behavior of what the sensor is. I have to have some way to go and ask for that. And so The sensor system I'm imagining has some ability to reset sensors and ask it for data, and within that I can ask it for the units. Is it English or metric units I'm going to get? And what's the sensitivity, or can that thing interact with the environment, or things like that? Maybe some of the sensors can. I have a little flashing red light that's on the sensor. Turn it on, turn it off, whatever I want to do inside of there. The monitors then, the behavior is real simple. I'm going to monitor stuff. I'm going to look for whatever state that's going on inside of there, and I'm going to have a schedule that I'm going to monitor it on. It's going to run according to that schedule. And then when I ask you, hey, go do your monitor job, you need to tell me, is something going on? And is it an emergency? Is it just informational? Say, hey, your room's a little bit dry. You might want to consider, watering your plants. Or is it, hey, the house is on fire, do something about it? That's the behavior side of this. So notice here, I'm talking about two classes. I'm not talking about full, huge systems, but I have a lot of detail going into these classes. Some systems are really dense like this. Some systems are, hey, I got 10 classes, not a lot of detail. Some systems have a lot of detail, a lot of things to go off. So at a high level, I can start to draw UML from this. Now notice I have no inheritance involved in this. I have this thing called a sensor, attributes and behaviors. I have this thing called a monitor, attributes and behaviors. I also threw in this result class out there because the result class gives me a feel for the data that will be coming back from the monitor. It gives me a little bit more feel of the behavior of the monitor. So I can see, what time did it execute? Is there an alert? What are the warnings? Is there a problem? Things like that. So at this point, I'm at a very abstract level in my design because I'm not dealing with specific monitors or specific sensors. And I got to make a choice. How do I deal with that level of detail? Again, when I'm designing my system, I probably have some physical devices in mind. I've gone to Acme store, if you're a Looney Tunes fan, and ran into Coyote there, and he told me the best sensors to go off and buy so you can drop anvils on little birds that run fast. So I'm going to go through those real sensors to determine how can I in software interact with them. What sort of things do they need to be? So if all the sensors fundamentally behave the same, and all that varies is these attributes I see inside of there, then probably I can use this sensor class as is. Each sensor becomes an instance, an object of this. Like you as a student, insert your name, insert your number. You're just a row in the database as far as the computer system goes. Not in my heart. I love you all. That could be a design. This could be the design, but most likely sensors have unique behaviors. They have additional features I want to do things. They have different ways they're going to query the state. Certainly monitors are going to have different behaviors. The smoke detector, the fire alarm is going to have a way different behavior than the time to water your plant alarm, which is going to have different behavior than a burglar alarm that's going to be coming in, which is going to have different behavior than the potential for freeze alarm, the exact opposite of the fire alarm. Your house is too cold, your pipes might freeze. All these different things that could happen inside of there. So let's look at an inheritance-based solution here. That's what our goal is to bring inheritance back in the picture. A couple different types of sensors. We'll start here on the left. We have a smoke detector. We have a thermometer. In this case, I'm saying the behavior is pretty much the same. The query of the state is going to be the same. We get some sort of text or string or number or something back. But what's different about a smoke detector is there's a smoke level, which is an integer, 1 to 10 maybe, or 1 to 100. How dense is the smoke? It's okay to have a 7 on the smoke detector scale. It's okay to have a 35 on the smoke detector scale, perhaps, depending maybe on the temperature. Maybe the two of these together are important. So the higher the temperature, the lower the smoke that's acceptable. Like if the temperature is 60 degrees in a room, it could just be, let's say 40 degrees in a room. It could just be frost. It could just be, like when you breathe, some vapor that comes in. So the smoke level has to be like maybe 90 to pop in. Where if it's 120 in the room, a smoke level of 10 is going to set off the alarm. And that's where the monitor comes in. So the monitor is a list of things. So for the fire alarm, it keeps track of both a thermometer and a smoke detector. It's going to keep track of these two together to get its work done. And the most important thing in fire alarm is it has a few details, temperature threshold, smoke threshold, something, there could be some level of combinations inside of there. But it has its behavior that is changing the behavior of the monitor. The monitor here you can see is an abstract class. It's italicized up here. And then there's a abstract method, so you can see it's in italics, that returns the results, and down here is where we need to implement this stuff. So from the monitoring state, hopefully you can see I can create a design that gives me the abstractions first. I'm understanding the system. As I look to implement that, I make that judge of, does there need to be different code? Are there additional data items I want to store? Or are there different behaviors I want to have happen? And boom, that can yield inheritance. This is what can drive me to a solution where I need to bring in polymorphism. I need to bring in these little triangles in the inheritance that's going on within my solution. So in your assignment this week, you don't have to do this level of design, but you do have to do some analysis. How do I string together these classes? What data is common? What is my inheritance look like? Is it 1 on top and 3 down below, or is there some levels of inheritance going on? That's a tiny bit of design, but this is the next step. It's not exactly super advanced. It's a little bit focused, but it's also not super simple. I'm starting from a very abstract but realistic problem and coming up with a possible solution for that. In the space we have, the amount of data we've shared. So keep this in mind as you go through and do design going forward. Keep this in mind as you talk about these concepts of coding inheritance, so you can remember how these things are shared, reused, and why we're doing it.